That star is Betelgeuse, perched on the shoulder of the mighty Hunter in the constellation Orion. Unlike the sharp white and blue stars scattered across the sky, Betelgeuse feels different. Warmer. Older. It has guided travelers, inspired myths, and helped ancient civilizations track the seasons. But what looks calm and constant from Earth hides a far more chaotic reality. In recent years, astronomers have realized that Betelgeuse is anything but predictable. Observations from advanced instruments, including the James Webb Space Telescope, have revealed something unusual. The star's brightness has been fluctuating in ways that don't match established patterns. Sometimes it brightens beyond expectations. Other times, it dims dramatically, as if something is interfering with its light. Stars like Betelgeuse, known as red supergiants, are expected to vary. Their size and structure naturally lead to cycles of expansion and contraction. But what's happening now goes beyond those typical rhythms. It suggests that something deeper is shifting within the star. To understand why this matters, consider the scale. Betelgeuse is enormous. If it replaced our Sun, its outer layers could stretch past Mars, possibly even into the asteroid belt. Despite having a relatively cool surface compared to smaller stars, it radiates tens of thousands of times more energy than the Sun. Its red color comes from that cooler temperature, but its power comes from sheer size and instability. Inside, Betelgeuse is in a constant battle. Nuclear fusion in its core is slowing as it runs out of fuel. Gravity, relentless and unforgiving, pulls inward. The core contracts while the outer layers expand. This imbalance creates massive convection currents, bubbles of plasma rising and falling like boiling water, except each bubble can span distances larger than Earth's orbit. This turbulent surface alone can cause brightness changes. But recent observations suggest something even more dramatic is happening. One possible explanation involves gigantic eruptions. Betelgeuse may be ejecting huge amounts of gas and dust into space. When this material drifts in front of the star, it can block or scatter its light, making the star appear dimmer from Earth. When the dust clears or shifts, the brightness returns, or even increases. This idea gained strong support during an event known as the Great Dimming. During that time, Betelgeuse lost about 40% of its brightness, becoming visibly darker in the night sky. Many wondered if it was about to explode. But later studies showed that a solid cloud of dust, ejected from the star itself, had temporarily obscured its light. That event changed how scientists view Betelgeuse. It wasn't just a quiet giant, it was active, shedding material and reshaping its surroundings in real time. Another possibility lies in the star's magnetic behavior. While not fully understood in stars this large, magnetic fields could be influencing how energy moves through its outer layers. If those fields shift, they might create hot spots or cooler regions, causing unpredictable changes in brightness. Mass loss is also a key factor. As Betelgeuse ages, it continues to shed enormous amounts of material, forming a vast envelope of gas and dust around it. If this process accelerates, it could signal that the star is entering a new and more unstable phase of its life. All of this points to one larger question: how close is Betelgeuse to the end? Red supergiants eventually die in spectacular fashion, in an event known as a supernova. When the core can no longer support itself, it collapses in an instant. That collapse triggers an explosion so powerful it can outshine an entire galaxy for a brief time. Current estimates suggest Betelgeuse still has tens of thousands of years before reaching that point. But its recent behavior has made scientists reconsider how precise those timelines really are. If it were to explode sooner, whether tomorrow or centuries from now, it would be an extraordinary sight from Earth. It could shine as bright as the full moon, visible even during the day. At night, it might cast faint shadows across the ground. And yet, despite the spectacle, it would pose no danger to our planet. It's simply too far away. What makes this moment special is not the certainty of an explosion, but the opportunity. For the first time in human history, we have the technology to observe a star like Betelgeuse in incredible detail as it undergoes dramatic changes. Every fluctuation, every pulse of light, every cloud of dust offers new clues. Betelgeuse has become more than just a star. It's a living laboratory. By studying it, scientists are learning how massive stars evolve, how they lose mass, and how they ultimately die. These processes are not just distant cosmic events, they are responsible for creating the elements that make up planets, oceans, and even our own bodies. The iron in your blood, the calcium in your bones, the oxygen you breathe, all were forged in stars like this long ago. Now, Betelgeuse is writing its final chapters, slowly and unpredictably. Whether its end comes soon or far in the future, its current activity is already reshaping our understanding of the universe. And as it glows red in the shoulder of Orion, it reminds us of something profound. The universe is not static. It is constantly changing, evolving, and transforming. Even the most familiar stars are not permanent. They live, enrank, struggle, and eventually, they fall, leaving behind the building blocks for something